Welcome back. Today we're going to dive into one of the most important concepts in programming, conditional statements. Conditional statements are used in programming to make decisions. They allow our code to run different actions depending on whether a condition is true or false. Essentially, conditionals allow your programs to be dynamic. Instead of always running the same set of instructions, the program can take different paths based on user input or other data. In this lesson, we'll cover various types of conditional statements like if, else, and switch statements. We'll also look at logical and comparison operators to see how we can create more complex conditions. Alright, let's start with the basics. What exactly are conditionals? Conditionals are programming constructs that allow different blocks of code to run depending on whether a specific condition is true or false. Think of it like making decisions in real life. For example, if it's raining, you bring an umbrella. If it's not raining, you leave the umbrella at home. The same concept applies in programming. Your code can behave differently based on conditions you define. Conditionals are important because they make your programs dynamic. Without conditionals, your program would execute the same steps regardless of any input or situation. By using conditionals, your program can adapt, respond to user inputs, and make decisions on its own. In Java, conditionals are commonly created using if, else, and switch statements, and we'll go over each of these in this lesson. Let's talk about one of the most fundamental conditional statements in Java, the if statement. An if statement is used to execute a block of code only if a specified condition is true. If the condition is false, the code inside the if block will be skipped. For example, if a student's score is 90 or higher, we can assign them a grade of A. Let's look at how that works in Java. Example, if score equals 90, grade equals A. Here, if the condition score equals 90 is true, then the code inside the curly braces is executed, and the student's grade is set to A. If the condition isn't met, for example, if the score is 85, the code inside the if block is ignored, and the program moves on to the next part of the code. So, if statements allow us to make decisions and run specific blocks of code based on those decisions. Now let's break down how to properly construct an if statement in Java. Every if statement starts with the keyword if, followed by a condition in parentheses. If that condition evaluates to true, the code inside the curly braces will be executed. Here's an example. If score equals 90, grade equals A, nice equals nice plus 1. In this case, if the score is 90 or greater, both lines inside the curly braces will be executed. The grade is set to A, and the value of nice is incremented by 1. Now, curly braces are not always required in if statements. If you only have one statement to execute, you can omit the curly braces. For example, if score equals 90, grade equals A, nice equals nice plus 1. However, be careful when doing this. Without curly braces, only the first line, grade equals A, is part of the if statement. The second line, nice equals nice plus 1, will execute regardless of whether the condition is true or false. As a best practice, it's usually better to include curly braces to avoid confusion and improve readability. Curly braces make it clear which lines belong to the if statement. Now that we've covered basic if statements, let's look at how we can make our conditions more complex using logical operators. Logical operators allow us to combine multiple conditions in one if statement, which gives us more control over how our code behaves. Here are the most common logical operators, and. This operator checks if both conditions are true. The code will only execute if both parts of the condition are true. Or, this checks if at least one of the conditions is true. The code will execute if either part of the condition is true. Example, XOR. This checks if one of the conditions is true, but not both. If both conditions are true, it won't execute. Not. This operator reverses a condition. If the condition is false, the operator makes it true, and vice versa. Logical operators help us create complex conditions and make our programs more powerful. They allow us to combine multiple requirements into a single if statement, which makes the code more flexible and adaptable. Now that we've seen how logical operators work, let's move on to conditional operators. These operators help us compare values and are essential for constructing conditions in if statements. Here are the most common conditional operators. Quit equals. This checks if two values are equal. Use this when you want to compare two values directly. Equals not equals. This checks if two values are not equal. Greater than. This checks if the left value is greater than the right value. Less than. This checks if the left value is less than the right value. Greater than or equal to. This checks if the left value is greater than or equal to the right value. Equal, less than or equal to. This checks if the left value is less than or equal to the right value. These operators allow us to build conditions based on how values relate to one another. Whether we're checking if two values are equal or comparing numbers, these operators are essential for making decisions in code. Now that we've covered if statements, let's talk about handling situations when the initial condition is not true. This is where else and else-if statements come in. Else statement. The else statement provides an alternative action. It tells the program what to do if the if condition is false. Essentially, it's a fallback option when the first condition doesn't match. Else-if statement. Sometimes you may need to check multiple conditions in sequence. The else-if statement allows us to test additional conditions after the initial if condition. It's used when you want the program to check more than one condition and take action based on which condition is true. With else-if, the program will evaluate each condition in sequence, stopping as soon as it finds a true condition. If none of the conditions are true, the program moves to the else block as a final fallback. This combination of if, else-if, and else statements ensures that your program can handle multiple outcomes, making it more flexible and adaptive to different situations. Let's dive deeper into how the else-if statement works with a real example. The else-if statement lets you check multiple conditions in a sequence. The program evaluates each condition one by one, and as soon as it finds a condition that is true, it executes the code for that condition and skips the rest. Here's a grading example. In this example, the program first checks if the score is 90 or higher. If it is, the student gets an A. If the score isn't high enough, it moves on to the next condition, checking if the score is 80 or higher for a B, and so on. If none of the if or else-if conditions are true, the program finally reaches the else block and assigns a grade of F. It's important to remember that the program stops checking conditions once it finds one that's true. For instance, if the score is 85, the program will execute the code for the else if scored equals 80 condition and ignore the rest. This method helps organize your code when you have several possible outcomes to consider. Switch statements are a powerful tool in programming for handling multiple possible values of a single variable. They evaluate an expression and execute the code block that matches a specific case value. Each case represents a condition, and the break keyword ensures the program stops checking after finding a match. If no match is found, the default block provides a fallback action, similar to an else statement. Switch statements are especially useful when dealing with scenarios like menus, days of the week, or other predefined options, offering a cleaner and more organized alternative to long if-else chains. Now that we've explored how switch statements work, let's dive into the essential keywords that make them function effectively. These keywords are the building blocks of a switch statement, ensuring it runs as intended. Switch. First, we have the switch keyword. This is where the switch statement begins. It evaluates the expression or variable that you're checking against multiple cases. Case. Next is the case keyword. Each case represents a possible value for the expression. If the expression matches the value in a case, the program executes the corresponding block of code. Break. Then we have the break keyword. This is used to exit the switch statement after a case has been executed. Without break, the program would continue evaluating subsequent cases, which can lead to unexpected behavior. Default. And finally, the default keyword. This acts as the safety net of the switch statement. If none of the cases match the expression, the program executes the code in the default block. It's like the else statement in an if-else structure. Let's see these keywords in action with an example. The keyword switch followed by a variable in parentheses, begins a switch statement. The contents of the switch are enclosed in curly braces. The keyword case, what the variable could be equal to, and a colon denotes the start of a case. A case continues until it reaches a break, or a. Alternatively, default can be used instead of case value as an else statement. In this example, the switch evaluates the variable number. If number is 12, the program assigns 1 to letters. If number is 2, it assigns 2 and exits the switch due to the break keyword. If neither case matches, the default assigns idkman to letters as the fallback. By understanding and using these keywords, switch, case, break, and default, you can create clear and efficient switch statements. They're a great tool for handling multiple possible outcomes in your code. Now try these on your own and determine what the output using the following code. These are the answers each input I. Input 1, first condition. We check if the result of dividing A by B equals 1, and also if the result of dividing B by A equals 1. Since both 1, 1 and 1, 1 are indeed equal to 1, this condition is true. Since the first condition is true, the program prints equal. Input 2, first condition. We check if a flash B equals 1, and if BA equals 1. In this case, 0, 6 is 0, not 1, so the first condition fails. Because of the way logical conditions work, short-circuiting, the second part of this condition, B where A equals 1, is not checked, as the first part is already false. Second condition. Next, we check if A is negative or if B is 5. Here, A is not negative, it's 0, and B is not 5, it's 6, so this condition is also false. Since neither the first nor the second condition is true, the program moves to the final step, printing bad. Input 3, first condition. We check if A B equals 1 and if B A equals 1. Since 4, 5 is 0, not 1, and 5, 4 is 1, the first part fails. So, the entire condition fails. Second condition. Next, we check if A is negative or if B is 5. A is not negative, but B is exactly 5. Since one part of the condition is true, the second condition passes. Since the second condition is true, the program prints nice. Input 4, first condition. We check if B equals 1 and if BA equals 1. 3R2 is 1 due to integer division truncating the result, but 2/3 is 0, not 1. Since the second part is false, the entire condition fails. Second condition. We check if A is negative or if B is 5. Since neither A is negative nor B is 5, this condition fails as well. Since both conditions fail, the program reaches the final step and prints bad. Final outputs: input 1 equal, input 2 bad, input 3 nice, input 4 bad.
Thank you for watching this video. Make sure you like it and subscribe.